Hi everyone, in this video we will have the types of discontinuities. So first we have the removable discontinuity. This happens if we have the limit at x equals c exists and either f of c does not exist or f of c is not equal to the limit of f of x as x approaches c. So this is also called whole discontinuity because our graph will have a hole. And this discontinuity can be removed by making f of c equal to the limit of f of x as x approaches c. So if we have this function here, f of x, we have a removable discontinuity at x equals 1. So at x equals 1 here. So we have here a whole. Here, the limit of f of x as x approaches 1 is 2. But f of 1 here does not exist because it has a hole here. So here we have limit exists and it's equal to 2. And f of c does not exist. So here at x equals 1, we have a removable discontinuity or a whole discontinuity. So since this has a hole, we can redefine this function and make f of 1 be equal to 2. So if f of 1 is equal to 2, that means to say when x is 1, y is 2. And we have there on the hole, we will put a solid circle. So this time, the discontinuity is removed. That's why it's removable. So the discontinuity now becomes a solid circle here. So no more discontinuity. It is remedied by making f of 1 equal to 2. That is why it's called the removable discontinuity. Okay, the second type of discontinuity is the essential discontinuity. We have two of them. First is the jump essential discontinuity. That happens when the limit of f of x as x approaches c from the left is not equal to the limit of f of x as x approaches c from the right. So it happens in this graph at x equals 2. The limit of f of x as x approaches 2 from the left is negative 2. And the limit of f of x as x approaches 2 from the right is positive 1. So they're not equal, so the limit does not exist. So it's called a jump essential discontinuity. And in this case, that is at x equals 2. And we have also the infinite essential discontinuity. So infinite essential discontinuity happens here at x equals 1. That is if you have the limit of f of x as x approaches c from the left or from the right gives you a positive or negative infinity. So in this case, as we approach x equals negative 1 from the left, the value of the function just goes up. So it's going to positive infinity. So we call this an infinite essential discontinuity. So the jump essential is what you can see here. There's like a jump here from this point to another. There's a jump. And then the infinite essential, there has to be like a positive or negative infinity as you move to the value of c from the left or from the right. This is called essential because you cannot do anything anymore to make the function continuous. So unlike in the removable, you can redefine the function so that the whole will be gone by putting a solid circle or a point there. So in this case, in the essential discontinuity, you cannot do anything to make it continuous. So these are the three types of discontinuities: the removable or the whole, the jump essential, and the infinite essential discontinuity. So if you will be asked at which point or at which value of x is the graph not continuous. So at x equals negative 2, at x equals 0, and at x equals 2. So there is a jump essential discontinuity at x equals -2. Here, this is jump essential removable at x equals 0, because we can remedy this by making f of 0 equal to 0. So if you do that, then we will have a point 0, 0. Y is 0 when x is 0. And then at x equals 2, we have an infinite essential discontinuity, because the function here, the limit of f of x, as x approaches 2 from the right, is positive infinity. So that's why we have an infinite essential discontinuity. So we have three types of discontinuities: removable, jump essential, and infinite essential. Very easy to remember. So that is it for this video. See you in the next video. Bye.